Hello, everyone. So we are restarting. Please take your seats.
Okay, welcome back from lunch. We're having a very exciting 1.5 hour in front of us with 8 presentations showing applications. We're going to talk about innovation, about AI, and all the things that excite us all. We start off with something that's called a conversation on innovation and smarter data solutions, but basically I'm just giving the floor to Fahad, who is president of GSTAT, the National Statistical Office of the Kingdom of Saudi Arabia. And we just had a chat during lunch, and well, they're doing great innovative things, so I'm looking forward to Fahad's presentation. The floor is yours.
Thank you very much. I have only one slide. If, before, thank you very much, Bert, and really glad to be here today. And congratulations to the organizers and also to the SDMX sponsors on the success of this conference. This slide is just to summarize the points that I want to cover. So I'll focus more, and I know I have only 9 minutes to discuss here. I'll focus more about our experience and what sort of business cases that we implemented. Technology is changing, bringing new sources of data. Also, demand is changing. The demand today for data and statistics has been changing rapidly in the past couple of years. As statistics offices, we do need to change. I was discussing with Bert. I'm really glad to see so many central bankers here. I was in the central bank for 25 years before moving to the National Statistics Office. Things are changing. We do need to change. For that reason, we invested heavily in our infrastructure, especially how we are managing data. Admin records and other sources of data are important to improve the quality of our statistics. We invested in a new project on the data lake where you have all the data in one place. It's been challenging, to be honest, when it comes to change management, especially many of our colleagues within JSTAT, they want to use their own environment, their own tools, instead of having one centralized platform. In addition to that, we have a very important project which was completed last year, building our registers, whether it's housing, population, and also economic entities. SDMX has been an important element for us to build our data structure and also to make it easier for us to exchange data and also automate exchanging this data domestically on a national level and also international. At the end, we are part of the international community, so it's important. And we heard this morning about a number of our colleagues talking more about speaking the same language, and this is where the systems, they should speak the same language. They should easily integrate with each other. On a national level, we are working in a national level statistics strategy, which can help us manage data in an ecosystem. Again, things are changing rapidly, so we have to also accommodate different statistical and data as well. The multiple sources of data has helped us improve the quality of our statistics. I'll give a few examples, I think, in the second half of our presentation, and how we used not only survey tools, which is very powerful for us to collect data. In addition to that, we use admin records from different government entities, and again, SDMX and other standards has helped us improve the structure of data and also make it easier to integrate. Big data, such as mobile positioning and other data, are important as well, and governance is important because privacy, as you're expanding introducing more and more data and different data sources, you have to be mindful also about the privacy and how we are actually protecting that privacy. Innovation and AI, and I'm glad this morning many of our colleagues here, they were discussing AI and how it's actually impacting our statistics and how we're producing the numbers. I'll speak about two sides. One, AI as producers of data, and also AI as consumers of data. As producers, our goal is to improve the quality of data. And we have two main examples that I wanted to share with you today. The real estate price index, which we introduced last year. So last year, before we introduced that, we used to have only one source of admin data, which is coming from the registrar, purely admin records, all the records of all the transactions, and we do some statistical calculations and then introduce the results. Last year, we introduced a new methodology using 3 sources of data from the registers, in addition to the Ministry of Municipality, where you have all the planning of the cities, in addition to the General Authority of Real Estate. So these 3 sources of data, we implement also a satellite imaging. Satellite imaging to give you real-time the nature of the land or the building or the house, etc. And then we used a GeoAI tool. The GeoAI tool will validate based on different criteria and whether it's actually correct or not, or it needs any correction. The quality of the number, the relevancy of the number has improved significantly, and this was actually produced in-house. And the good thing about AI, many of them, they are open source, so it was very helpful for us to use these tools. Another example was the CPI, which I was discussing with Bert. Last month, we introduced the new CPI. We introduced our chain linking and the CPI, but in addition to that, we started using admin records in addition to scanner data. The challenge that we face with scanner data is the classifications of different products. So we use an AI tool to help us improve the quality and then also make it easier to produce the indicators as well. So this is the producers or the data producing side. Data consuming side, and again, because of the demand is changing. The demand not only from government entities, private sector, but also from the public. Now everybody wants to see more of these statistics, of these data as well. In addition of having our portal, our website, and micro data center, but there are many issues in how you raise awareness, how to understand the number. A year ago, we wanted to introduce a chatbot. And it's been challenging because we wanted this chatbot to answer one simple question. For example, what was the GDP in 2019 and how was calculated? And it was very difficult for us to, and I'm glad the IMF is actually working on something that we can learn from it. And I think we do need to understand what the users are needing and also what's the demand. This is my final point. Again, I think the SDMX has helped us tremendously in the past period, but I do agree with the discussion today. It has to evolve, it has to also accommodate the changes that happen in technology and AI, and looking forward also for more standards that help us globally as well, dealing with the AI and the changes in technology. Thank you very much.
Thank you so much, Fahad, for presenting this. And it's clear that we can be successful if there's a combination of strict standards like SDMX, like the CPI manual, like the SNA, combined with innovative approaches to actually estimate the data. So we cannot do without the standards, and we cannot do without the innovation, but you combine them too in Saudi Arabia. So compliments, and well, you were there last global conference, and hope to see you next one as well.
Thanks.
And good travels back.
Thank you very much.
Thank you. So yes, now we're gonna move to session 2, Bert, and because it's very crowded, because there are some presentation with multiple speakers, we're gonna ask the first 3 presentations to be here in the podium, and then once they're done, we do a little like a switch. So I think it's Jens, Lisette, and Alessandro, and your name? And Bianca, yes. Yeah, over to you, Bert.
Okay. Yeah, we have 7 interesting, important presentations. SDMX empowering AI, AI empowering SDMX. And I think the first presentation is by Jens Dossé, who's leading the Smart Data Solutions team at the OECD Statistics Directorate, but also co-chair of the SDMX Technical Working Group, so a person particularly fit to illuminate us on this topic. Jens.
Thank you very much. Good afternoon, ladies and gentlemen. My topic is SDMX data AI ready? And is AI SDMX ready? So maybe an introductory presentation. I will not go through the outline, you will see later. So my first question is, what is AI? Of course, there is no time to explain all the technical details, but what is most important is that AI is a moving target. So there are new developments all the time, and what I tell you today might already be wrong tomorrow. And when we talk about generic AI and specifically large language models, they predict the next word in a piece of text, which means 2 different things. One is there's probability involved, and when you say probability, you have a risk of error that we call hallucinations. And the second part, that these models work best on text, but not with numbers in a statistical database. So we need to complement these large language models with components that can get data from databases. And so as we have seen earlier, StatGPT, MCP, so these technologies can help there. Yeah, also to introduce the topic, maybe we can look into 2 use cases, and I believe here within my presentation the dissemination domain is the most important, with one use case making ourselves, the statistical data, more findable and accessible, and the other way around, making the AI tech leaders use our data appropriately. And so you see here there is a push way and a pull way in these use cases. I asked Copilot to actually tell me what it needs in order for statistical data to be AI ready. It gave me actually a very nice answer that I cannot go into details, you can read them later, but they range from data quality over data structures and formats, semantic clarity, through metadata and documentation, contextual relevance, legal and ethical compliance, and towards technical compatibility. So there are quite a lot of things that we need to look into. Furthermore, when we talk about AI readiness, maybe a better term would be AI optimization, because there is no level that can really be achieved and when you're ready forever, but it is a continuous process where we can always improve and get better over time, similar as what we have done with search engine optimization in the past. And second aspect I would argue is also whatever we do for AI readiness or AI optimization is also good for humans. And you will see later more details. And actually also our presenters have mentioned this. So yeah, is SDMX data AI ready? First of all, as we have seen also earlier, it provides a standardized container, which means the information model, API formats for data transmissions and storage. And we have also mentioned additionally potentially a model context protocol service as middleware. This makes our data discoverable, machine accessible, and up to date, and hopefully also then open to the public. And it contributes to timeliness, accessibility, and system interoperability. The second aspect of SDMX, that it helps to standardize our content. So we have SDMX guidelines that allow us for high quality data modeling, and so we can achieve well-structured, well-identified, and semantically versioned data, which leads us to coherence. And we also, all of our statistical organizations probably have statistical quality framework that contributes to relevance, accuracy, and credibility, and all of that builds trust. But most importantly, the standardization also concerns data harmonization within the organization and at international level, which was mentioned also by IMF before. And this is very important to maximize the data consistency and comparability. And the third aspect is that our data are often massive, and so we try to optimize the data to make them small. So our metadata often are very small, where we use identifiers, codes, and so on. But to make them AI ready, we need additional descriptive metadata, clear definitions, and context at all levels, explanatory documentation, including for legitimate anomalies and biases. We can also add standardized semantic relationships between the data beyond harmonization. So for instance, provide knowledge graphs as linked open data. And last aspect here would be to add an ontology-based international standardization of meaning. This work currently undergoing in the TWG. And this will make our data understandable and interrelated, and so enhance interpretability and transparency. Again, it's a factor of trust. So yeah, actually there are some gaps in the SDMX standard itself for AI optimization. And you see here a picture actually of the technical working group hard working on these. The first, the first aspect, or the first task, is to create persistent, resolvable SDMX identifiers thanks to the brand new SDMX Global Discovery Service that will be presented later. And this contributes to making SDMX fulfill the FAIR principles. Then, as mentioned, so the SDMX information model will be expressed as SDMX ontology linked with other existing ontologies. And lastly, we will make SDMX data linked open data ready by allowing for flexible semantic linking mechanisms between identifiable artifacts and external contexts. So the last question is AI also SDMX ready? So the other way around. And yeah, indeed, AI agents can connect already to dataset catalogs that some of you provide on the internet, where they translate SDMX into schema.org or DCAT or similar. But as we have seen, these tech players, they can also use our SDMX API, and Google just mentioned that they are ready for this. And we have also mentioned model context protocol services that can be powered from SDMX sources, so this would be an additional option here. However, is this sufficient, or do we need something else? And I think what is very, very important in this area is collaboration between all the statistical offices in order to talk a common voice with these tech players. And so have a coordinated approach. And lastly, the tech providers, they should return services in terms of visibility of our data, feedback, and support. Later on, you can look at these additional annex slides that I will not go into detail. One is on capacity building for AI readiness, so what you can do within your institution, systems, and with the individuals to progress on this matter, and also how to overcome common challenges in implementing AI-based systems. So to conclude, What do NSOs need most to become AI ready? This was a question asked in the OECD COSTAT Global Conference 2025, where actually I picked up also a number of nice ideas for my presentation, specific thanks to Olivier Dupré from World Bank and François Fontenot from OECD. And to answer the question, yes, so you see here some participants have answered SDMX. This would have been my first choice, but indeed, as mentioned during my presentation, we need very hard working on data harmonization, augmenting our data with descriptive metadata and linked data, and finally, we need to work on governance. Thank you very much.
Thank you, Jens. And it's great to see that your presentation is so much aligned with what we discussed this morning. And thanks to OECD, Eric and Steve and the others working and progressing so much. I really like the picture of the technical working group. It really looks like there's a lot of work actually practically going on, and it's the only thing we can really get results. So thanks for this. Next presenter is Lisette Traconis-Lugo, who's currently Director of Data Integration and Databases at INEGI, the National Institute of Statistics and Geography in Mexico. So, Lisette, the floor is yours.
Thank you. Can you? No? Thank you. Okay. Good afternoon, everyone. Thank you for the opportunity to share information with you. I would like to start with a bit background about the topic. As you know, technologies related with artificial intelligence is growing and evolving, but we recognize that we have a challenge, and it's not just a technical challenge, it's also a strategical opportunity. At the National Institute of Statistics and Geography in Mexico, a team of the IT department is working on an initiative in order to demonstrate how SDMX can be used to enable AI-ready data. Now let's start by understanding the core challenge here and why SDMX is key for AI-ready data. As you know, AI models requires data, especially LLM models, requires data that are standardized, meaningful, and machine-readable. And when the information comes fragmented or it lacks of metadata, it becomes even harder to use and prepare effectively with AI. That's where SDMX comes in. SDMX is an international standard to provide or to improve exchange in official statistics, but also help us organizing data consistently, adding rich metadata for context, using machine-readable formats, and promoting semantic clarity through standard concepts. All these features makes SDMX a key enabler for AI-driven data environments. Now, let me talk about how we organize data at INEGI, at the Institute. We have a transversal data platform that is made of key parts. The first one is the processes that are responsible to collect and create data from different sources. Then we have data ingestion mechanisms that brings all this data into databases and repositories. And this information is stored with detailed metadata in order to help the dissemination process that is made up from different information delivery mechanisms. And one of these mechanisms, I would like to highlight this, is SDMX API. With this, we can share information through different systems, like digital information services and other tools, third-party tools. This well-organized platform, combined with SDMX, help us prepare data that is ready and suitable for AI applications. Now let me walk you through two different use cases we're working on, applying AI to SDGs data with SDMX. These use cases aims to demonstrate how the SDMX enables AI-driven exploration of SDGs data through two concrete use cases using two distinct AI architectures, each solving different data interaction challenge. The first one is information retrieval architecture, and the second one is an IA agent for dynamic queries. It's important to highlight that both use cases rely on a solid knowledge base, as you can see, like a metadata list, DSD matrix, data flow from SDGs datasets, and this helps to have a solid base information. Okay, now this is the architecture of the first use case. As you can see, the first use case focuses on information retrieval, allowing users to ask natural languages questions and retrieve structural metadata components such as DSDs, data flows, and SDGs indicator metadata, which are processed by a Python-based ETL. The output is converted into narrative text and embedded into a vector database. When a user asks a question, the system retrieves the most relevant text fragments using semantic similarity. These fragments provide context to the LLM, which then generates a natural language response based on the retrieved content, returning a clear and informed answer to the user, one that is based on the SDMX data and metadata behind it. This is one of the results of the use case. As you can see, I think I will. Okay, it's okay, okay. I lose one slide, sorry. Okay, this is another example for this use case, and the knowledge base is the DSD matrix, and it helps the AI system to retrieve information about measures, dimensions, and attributes. Okay. This is the other one architecture we are working on, and this is an AI agent architecture for dynamic SDMX queries. This slide presents where an AI agent is used to handle user queries instead of relying on pre-processed embeddings. The agent interprets the user questions in real time and extracts the necessary parameters, like indicators, code, time period, or geographical level, based on contextual documentation provided by SDMX code list. It then uses those parameters to build requests to the SDMX API, retrieves live data, and presents it in charts and plain text summary. This setup is especially useful when a user wants an actual data or online data. This is the use case result. As you can see, the AI system retrieves the data and make a graph and a little description of the graph there. Finally, I would like to, okay. Now that we've seen that two architectures, I would like to summarize why SDMX is important for two of the main parts of the preparing data, that is data preparation and data retrieval. For data preparation, we can standardize data, and APIs enable automated extraction, simplify transformation, and allow a single ETL process for all data flows, making updates faster and easier to manage. On the right, under data retrieval, SDMX helps again. Standardized metadata and structured data improve semantic understanding, support consistent queries, and help align users' intent with content, leading to more accurate and meaningful AI responses. And finally, I'm going to close saying that getting data ready for AI is not just a technical upgrade, it's a transformation in how we manage and share information. That's all, and thank you very much for your attention.
Thanks, Lisette. Very, very interesting, and it's good to see that many of the use cases people working on are similar. So it's good to have a community to learn from each other and work together. So thanks for this. Now we have two presenters who choose to do it standing, which is fine, but they still have 9 minutes together. Alessandro Benedetti, who is director at SEAS Limited, an Apache Lucene solar committer and chair of the product management committee, so a fan of open source, I guess. And Bianca Ligani, statistician at the Bank for International Settlements. Raphael is also on the list of authors, but I don't see him standing, so I guess it's the two of you. Here's Raphael from BAS as well. Okay, the floor is yours.
Okay, thank you very much. I'm very happy to be here today with Alex to present you a joint work from the BIS and SEAS about how AI, and in particular, not surprisingly, large language models can support the navigation of SDMX data. The solution that we will present today is tailored for the BIS data portal, but the good news is that it was developed in a way such that it can really be reused against any SDMX compliant API. About our data portal, it was launched a bit more than 2 years ago, and it is completely based on SDMX. It hosts right now a bit more than 1.2 million time series divided into 27 SDMX data flows. In terms of usage, what we see is almost 10,000 users per week, of which almost 1,000 users every week is using our text search functionality. And currently, our text search in the portal is based on Solar from the Apache Software Foundation. Solar is a well-known engine for text-based search on big data sets. We've tried to enhance it by implementing synonyms and abbreviations, but what we realize is that for users, it still requires quite some technical knowledge in order to successfully run some text search. So I will now briefly present you the use case and the related challenges, then hand over to Alex for the AI implementation, all the technical details. I will leave it to you, Alex, and then end up with a quick demo. Promise it will take 10 minutes. Starting from the challenges, let's imagine a user wants to find out what are the office space prices in Rabat. This is data that we have in our BIS data portal. You can see here a screenshot. Following the SDMX structure of our portal, the first thing the user would need to do would be to look into our category scheme, go through all categories, and pick the relevant one for the query, which in this case is commercial property prices. So they would navigate on this page in the user interface, and then they would see all the dimensions of the DSD. And dimension by dimension, they could click and pick items from the code lists. So for instance, for the dimension reference area, they can select Morocco. And for example, for the dimension real estate type, they can pick office and retail. And this would lead them to the data. As you can see, this is a quite simple data set, but it still requires some knowledge of the data. So we were asking ourselves, what if AI could support the user in doing these steps? What if the user can just ask a question in plain, natural language, and the system would apply these filters for them? And maybe in this process, the user could also learn something more about our data. And I hand it over to you.
Thank you, Bianca. So, an AI assistant for filtering. What are the goals of this system? So first of all, leverage SDMX data and provide this data to a large language model to effectively support the search process. This allows natural language query to happen in the search box and explore the data in the BIS data portal. This solves the problem that you may have experienced in search, in traditional search, which is the vocabulary mismatch problem. So when the query terms used by your users don't align with the terms you have in your corpus of information. And in addition to that, we can use large language models to explain this to the users. So why, for a certain query, a certain topic, a certain filter was selected, and this is quite powerful. To conclude, the last goal, of course, quite important, is to provide this solution in a way that can be shared with other central banks and international organizations. For this reason, we plan to open source the solution. A pre-processing step is query moderation. So we want to clean the user query. We want to make sure that the language used by the users and the intent of the users aligns with the BIS values. So we don't want anything offensive, for example, to go through the large language model and through the response. To provide this functionality, there are different steps. The first one is just keyword moderation, so checking the keywords in the user query. And the second step is using the OpenAI moderation API, so using the large language model capabilities to make sure that the response is going to align with the BIS values. How does the flow works for this assistant? So first of all, we are talking about a REST API that is capable of processing a natural language query and return a set of filters selected with the motivation of the selection. On startup, SDMX artifacts are fetched from the registry, and then category schemes, data flows, dimensions, code lists, and dimension values are cached and used as a dictionary. This dictionary is going to be the input along with the user query for the large language model to give a structure to the query, to the user query. Then there are 3 steps. These steps look quite similar to each other. So the first one is topic selection. So from the category schemes in the dictionary extracted from SDMX, we select the best topic for the natural language query, plus the motivation. Then we follow up with the reference area, which means we go through the country-related information in the user query, and we select the best fit from the dictionary extracted from SDMX. In each step, we restrict the dictionary only to the data flows that are compatible with the information selected so far. Finally, we go through the dimensions, so the remaining values we want to effectively add in the filter suggestion to the user. So this was possible thanks to a feature that's been recently released. I mean, talking about probably 1 year, but anyway, still we can consider it recent. The structure output and JSON schema capability, which is a way to limit the text generated by a large language model to a specific structure well defined in a JSON definition. So these allow you to specify, for example, the list of dimensions and the values that are possible for a certain dimension, and a specific JSON structure that you can reuse across different services that can interact. And in this way, we made sure that it's always a JSON and is always a compatible JSON. So this was vital to reduce hallucinations where, for example, a wrong value was associated to a wrong dimension, for example. Some future works, we want to integrate few shots prompting, so adding some examples in the prompt to make it more reliable. We did some experiment already, and we're going to experiment more and evaluate more, actually enriching the way we built a test framework thanks to domain expert and large language model as well, that created more examples to make it more exhaustive. we may evaluate the possibility of fine-tuning and using distillation to reduce the capabilities from the large language model that is quite an overkill for this kind of problem, just to a solution that's just specific for the task. Once in production, collect feedback, both implicit and explicit, and then do some iteration in improving the prompt, and finally make it open source. We're going to have now a quick demo by Bianca.
Thank you. It's going to be very quick. What you see right now is the user interface of the BIS data portal. I already typed the query just to run as an example to you. And when I launch the query, first of all, I would like to highlight that this is not yet our public production environment. It's an internal prototype. Two things are happening right now. The first one, at the bottom of the screen, you see the traditional Solr search results, which are 0. Nothing matches these very specific words. And on top, you see the results of the AI assistant. Before I click on the results, I actually click on the reasoning. Here is where the user can actually learn why some choices were made. Just for instance, there is a topic reasoning that explains that this query relates specifically to market prices of commercial real estate, therefore commercial property prices was selected. And if then I click on the link suggested by the AI assistant, I end up in the commercial property prices page. Filters were applied, exactly as we were expecting. Reference area is Morocco, covered area is the capital city, and real estate type is office and retail. So the user didn't have to click through all these dimensions one by one, but they get straight to the data. If we could go quickly back to the slides, maybe. Yeah, I think Rafael has some remarks for you.
Yeah, so as Alex and Bianca already said, we want to bring this software solution to the SDMX.io page to make it available to everybody. Because as you see in the first bullet point there, it works actually against every SDMX compliant web service. So if you have an SDMX compliant API, you can also use this. We also want to make it available because a lot of you have great ideas. So if you want to contribute, the repository is meant for collaboration. So please send us a pull request and we can incorporate this so that we can again distribute it to a wider audience. SDMX.io was already mentioned a few times. In the SDMX community, a lot of us are producing great open source software. And 1 or 2 years ago, we basically decided to consolidate this in this new SDMX page, SDMX.io. You can see that every month we onboard new software to that page, and that benefits all of us. So please have a look at this, use it, download it, collaborate, or even upload your own software. That's it from my side. Thank you.
Thanks, Bianca, Alex, and Rafael in the end. It's a great example where a rigid structure like SDMX really promotes innovation, and another example where you can prevent hallucination by, well, suggesting data sets are there. So it's really great, and SDMX.io is a good way to share all this and a way to cooperate. So thank you for your leadership here. So I guess...
Yeah, I think we need a change of speakers now. Thank you. Thank you, Jens. Thank you, Lizette. Thank you, Alessandra and Bianca. So I'm going to call here Giulio and Alberto and Shutong and Simone and Davide. Hope you're all here. Yeah.
What's that? Yeah, here and there. It's not. Maybe to send it's better to sit there. Okay, we have 4 more interesting presentations to go. And the first is by 3 presenters. Phil Bright is Manager of Data Services and Dissemination at the Pacific Community Statistics for Development Division. Julio Dalla Riva, Statistics Advisor for Data Systems at the Pacific Community. And Denise Grofield's advisor in statistical process modernization at the Pacific Community Statistics for Development Division. So looking forward for your experiences. You're on this side.
Thank you so much. How do I interact with the screen? Yeah. Thanks, everybody. I am Giulio, and I'm going to talk a little bit about what we're doing with AI and LLM in the Pacific. I come from the Pacific Community du Pacific. And the main take-home message is try to do small modular things rather than trying to build huge Molochs. We all want to introduce LLM for SDMX. We want to improve user experience, and we want to improve developer experience. But we know there are some challenges. LLMs are error-prone. They are mathematically unavoidable to make mistakes with LLM. If somebody tells you that LLM get 100% right, they are hiding something. LLMs are expensive. They are expensive. They might be paid by token, but a token roughly corresponds to a word. So for every word of input, you pay something, and for every word of output, you pay something. They are expensive both economically and environmentally. So we should try to use things in a sustainable way. LLM pose cybersecurity risk. Nobody ever fixed completely the cybersecurity risk posed by LLM, especially if you put all your data into an LLM, and if you transfer your data to an LLM service, which is shared with others. If you have private data sitting there, it's very, very challenging to grant full security there. The other challenge comes from the SDMX side. SDMX is extremely rich semantically. It is a wonderful format, but the structures that are coming with SDMX are very long, and sometimes these pose challenges to the AI. So how do we try to fix these things? Because LLMs are error-prone, I think that a wise approach is to provide help to the users, not the answer. If you provide directly the number, there is no disclaimer that holds. The user will trust your number, and it might be wrong. Try to provide help, not answers. Prefer the use of very light local LLM. Pay for a small server, not for a third-party service. Do not send your microdata to the LLM. It is probably an overkill in any case. And we need to work on simplifying and summarizing SDMX when we work with LLMs. A couple of use cases. I start with a use case, which is the search for indicators in a large collection of indicators we have. There are around 100 indicators in this dashboard. They are nested, and they are phrased in a very specific way. The word match, exact word match that we are used to, doesn't always work very well because the user needs to know exactly how a certain indicator is phrased. We can, on the other end, oh, these are the old slides. They've not been updated. Okay. We have implemented a RAG-based search. What that means is that we have implemented a small LLM-based system to search for indicators. What the AI tries to do is, instead of doing a word match, it tries to do AI semantic guess. It does work, what we have built, it does work, we have tried it out. Work in this case is a little bit vague because there is no hard benchmark of what a user was searching. Sometimes they're searching for things that are not there, but it does provide an answer, which in our experience, it is a good answer. It's been said many times, the quality and completeness of the metadata is key. It is very fast, and it costs almost nothing. All the system works on a 2 gigabyte server on the cloud. There is no requirement for anything more than that. It is very simple from computational point of view, and you can keep it simple. And it is actually very simple. So things that are built for AI right now, many times boils down to very few lines of code. This is actually working prototype of that in Julia, and it's what, 10 lines of code.
The actual challenge is not in the AI part, is in the classic software development part. You need to handle APIs, authorization, and things like these. But these are very classic things that have been abundantly solved for the web development people. So it's simple. We can do modular small things. It doesn't try to do everything, but it works. One thing that we did is that there is an issue with translating SDMX to LLMs, so we did implement an MSCP. We have a model context protocol working. It does allow for the progressive discovery of data. Here I would have the pictures, but basically you ask an LLM, whatever LLM that the user is already paying for and they want to use. It can be ChatGPT, but it can be Claude, DeepSeek, the Swiss one, whatever. And the LLM is able to interact with an API that we built, which is basically translating and making it easy, SDMX for the LLM. And it allows for discovering how to fetch the data. The model context protocol that we have does not give back an answer, but asks the AI to provide the code to fetch data. The added advantage of that is that in that way we solve the issue of crossing different data flows. The LLM with that MSP is able to actually fetch many different data flows across the data and provide a unique table coming from different data flows at the same time. It is not constrained to just one data flow. It is fast, it is cheap, it is light, because it is not AI. The MSP is just a classic software product which is translating SDMX to LLMs. It is not doing any AI, so it is very cheap and fast. And the other small things that we did is that one of the other things that we tried was integrating SDMX and AI into the programming experience of developers. So we recently launched a Julia version of an SDMX parser and reader, which also include LLM-powered ability, so that you can ask, you have a rough data source, and you can ask that bunch of libraries to translate the raw data in input that might not be SDMX compliant in any way to be transformed into LLM compliant, an SDMX compliant CSV. Again, what the LLM will provide you is not the final solution, but it is the draft of code that the user can modify in order to get the required result. So what did we learn so far? In our small approach, we don't need to deploy large GPTs. Deploying large GPTs is something which is very expensive. Big companies can do that, but for us it is way easier to produce small, modular, open access tools for LLMs that everybody can play with and implement, which provide also the ability to not have to pay for the AI build for everyone. If you have your own ChatGPT and you are running it, or if you are paying yourself for the third party, that is going to be very expensive, but with things like MSP or small local LLMs, you avoid that cost. So you don't have your organization paying for everybody AI. And it also allows you to maintain sovereignty over the tools and the data. You're not putting all your data somewhere else, and you're not relying blindly on third parties' AIs. And most of the challenges that we had to solve were actually very classic software development challenges, things that are being faced by every dev in the last 20 years or 30 years. Nothing fancy there. Thank you so much.
Thanks, Julio. This was really impressive. So much information, so many sheets in so little time. But it's really good, and the lean approach to this really helps, and I like the things about having sovereignty about your own data, and it's so important to have that, to ensure data is well represented and referred to. Thank you. Okay, so the next presenter is, let me see, Alberto Sibilo. a data engineering consultant with UNICEF's Frontier Data and Tech Unit, part of the data analytics team. So, floor is yours.
Thank you very much, Bert, for your nice introduction. I want to present this work that we frame as contextualizing SDG through SDMX and Gen AI. This has been done in the Frontier Data and Tech Unit, led by Yves Jacques, which in turn report to the chief statistician of UNICEF in the data analytics section. So now there for more than 10 years that UNICEF has been reporting on SDG progress, but 2 years ago a new benchmark methodology was introduced that allows more clearer comparison, let's say, across indicators. And what we have learned is that when the analysis is presented to her with a narrative, then in country offices, stakeholders and decision makers really engage and think this is useful. But we have produced this for more than 200 countries, and really the vast majority are not read nor used. And this is not just a challenge of our organization. Recently, the UN has reported that even the reports number has increased about 20% in the last 30 years. Only a handful of them are widely downloaded, and that really doesn't mean that they are used. So before I get into the opportunity and challenging on how do we make this country risk more compelling, let me just briefly go on how SDMX stands within the UNICEF data lifecycle. UNICEF tracks indicators related to children well-being on different units that we call health, immunization, education, so on and so forth. This really comes from heterogeneous data productions, meaning that analysts will use different scripts, different script languages, multiple sources, but at a certain point when these indicators are harmonized, each unit would push to the SDMX data warehouse. And this means that when a transversal product such as the SDG, transversal in the sense that there is one lead team that need to use the data from across all other teams in UNICEF are going to be able to do this. So for us, SDMX is not just complying in a standard, but it's the glue that allows this integration across teams. Then, in particular, what do these SDG country risks show? I think I could summarize this in 2 plots. So this benchmark analysis reports on what we call levels. These are the blue dots over there. These are the latest data points that country reports on SDGs, and these are ordered in comparison to all other countries in the world latest data point reported. So you have this percentile quintile that orders them. And also how the yellow dots over there, that is the national targets that the country has set, how do these fall within the same scale? And the speed, that is the plot below, and the green dots are the mean performance speed in which countries using latest 25 years of data history. How is the mean speed at which countries has been either advancing or going back in terms of changes change of rates, right? Rates in terms of these indicators. And how these also compare with the red dots. That is the expected speed at which a country needs to perform to take the latest level up to the national target. So this easily becomes really overwhelming without a narrative, and without a narrative, really it's difficult for country offices and decision makers to interpret or act upon. Well, sorry about that graph. I'm glad that the vector graphics, let's say standardization, is not working very well. That is a vector plot. Really the challenge here is how do we transform country briefs into actionable narratives now and make this in a scalable way, right? It's just a nice plot. There is really not relevant information. But now we have a scalable workflow, but it's a very stiff template. So we can change country names variable, we can allocate the proper plots, but there is nothing that is contextualized, not tailored in these country briefs. So what we want to use is the power of LLMs to summarize and get insights and ground this based on the data that we know. So statisticians know how the benchmark analysis work. They don't want Gen AI really to do any calculations, but they want to summarize. So the approach is combine SDMX data, contextual documents, and LLMs. What we have what we have put into place is the integration of structured data, contextual documents, and LLMs in a modular pipeline. So our inputs will be a data flow in a SDMX data warehouse, context documents, for example, economic reports from World Bank, that is a handbook, let's say, of the latest 3 months on how countries are performing in terms of economic indicators. So everything that domain experts can drop into a SharePoint folder, from which we are going to perform a retrieve augmented generation and a config-driven file that will say, okay, in this report, we want to have this and that plot, we want to keep this text, and we want to use a certain prompt that we're going to ask upon this data to get certain insights. This workflow is in essence a Python code that stores in Databricks. It will pull documents from this SharePoint folder to build the vector database to perform the RAG. It will pull data from the data flow in SDMX to feed the context window where we're going to ask these questions, and use OpenAI models in Azure Web Services, which is our provider in UNICEF. All these outputs are brought together in a library that essentially is able to render this nicely in a PDF that we will push back to SharePoint, because in terms of quality assurance, we really don't want to just build text and publish, but we want to involve the domain experts in this process. And we have figured out, we are testing doing this in a semi-automatic way, in the sense that we are using an open source library called the Eval that in essence can use the same LLM or other to come out with a score. This score will be like a precision recall kind of statistical score based on some other prompt that we put in this config file that will do either a factual consistency check or a more general test over the prompt, so as to allow the analyst to say, well, maybe if I need to read 200 reports, I should start with these first 10, which have the lowest quality scores in terms of evaluation. So, so far what I have presented is the integration then of this GenAI into this workflow. We have devised this to do it with reusability in mind, in the sense that generating, so having structured data, today is SDG, but tomorrow could be another data flow in our SDMX data warehouse. Again, the contextual documents may change, but the core exercise there will essentially, we have devised this with reusability in mind. To acknowledge that this is really a testing, and what studies show is that moving pilot to productions in GenAI has been only 5% of the last 2 years projects in corporations. So this is a really challenging, and what I think cross-collaboration is essential. That's my opinion, particularly because our team, we are the data engineers, so like the Mario and Luigi Bros Nintendo characters. So we build the pipelines of a workflow, but we really need the domain specialists, in particular here, the fine-tuning of the prompts and the capacity to take this to another steps in terms of reliability and accuracy. And with that, I leave it and over to you. Thank you.
Thank you so much, Alberto, and I agree on many fronts. If we want our data to be used, giving context, telling something about it is so important, and the context you could describe to clearly see why it is needed. Another example where standardization and SDMX make this innovation possible, and it's really interesting to see this. And hearing from you as a data engineering consultant, you need this cooperation with experts is also very encouraging, because I really believe that this cooperation makes things really successful. So yeah, great presentation, thank you. Next one is Shutong Ding from the ILO. He's a knowledge management officer in the Department of Statistics. So, and part of the SDMX Statistics Working Group. So, the floor is yours.
Yes.
Oh, you're here already.
Yes, thank you, Direct Chair. Good afternoon, everyone. Let me begin by thanking Bank of Italy and the organizing committee for having this important event. The ILO, as a proud member of the SDMX initiative, We are very pleased to be here to share one of the most impactful program that we have been benefiting from SDMX, the Labor Market Information System, LMS, and also its latest development with AI. So to introduce this, I would like to invite you to imagine with me together and to fast forward a few years ahead. Imagine in 2027, we have a labor market intelligence system that can automatically generate labor market trends, insights. For example, there's a message pop up on our screen. Use professionals with the SDMX certification have a 30% chance higher to get a job. So such a system combining all the information coming from different agencies and without hallucination, and this is something that we're dreaming about in front. And today you see a sort of baby version of this where we try to build applications in AI to draft analytical reports from the SDMX data. A little bit background on SDM Labor Market Information System. Since 2018, ILO has been supporting countries to develop LMS. It's not only just about data consolidations, but also we help in the institutional arrangements on data governance, and also helping to build the local capacities and champion the open source tools like DOSTA Suite, which is also having the SDMX compliant. Today we have nearly 30 projects covering more than 50 countries globally. And with more and more system into production and also data perforations, we are seeing both opportunities for insights, but at the same time we're facing the analyst challenges that how we're gonna analyze this large volume of data. So this is where we motivate us to look at how the generative AI can help. Just a quick example of the LMS data portal. Here are two quick facts. One is that the labor indicators typically come with a demographic breakdown, such as like employment by sex, age, and employment by sex and education. Secondly, those information, we can easily capture thanks to the DOSTA Suite. It's possible to retrieve it directly through API, both metadata and data. So before designing the solutions, we run a quick feasibility check. And we know that the data we're dealing with is aggregate level, and there's no micro level disclosure, and it's well structured and harmonized. And we also can retrieve data through API. And then generative AI, very powerful. But do we have any existing AI tools that can achieve this by directly prompting? The answer is not yet fully achievable. We look at all even the super agents, but it's not. We find that it still requires a dedicated AI-driven workflow and also a structured prompting, incorporating all the expert knowledge from the labor domain. And finally, we decide to go for a web application, which with minimum configurations and centralized deployment. Of course, the idea here is really try to start to draft the initial draft. It's not a final, requires a human validation. At the same time, it's not replacing the analysts. Just to highlight, what generative AI could help in this context. It supports multilingual naturally. And also it has, it can ingest the domain knowledge and also reporting styles by integrating the reports that previously have. And also naturally it can draft the analytical reports, but also creating the codes for graph plots and so on. And most importantly, it can reproduce the similar tables to others. Sort of effort is this. But the results, of course, the exact results may not be guaranteed. So the final solution that we started the development from the beginning of the year, and now we have sort of prototype of the solutions. where we have 3 core functions that in mind. The first one is the single table analysis, where when the users to pull from one data flow, we're able to generate the graph codes and also the report and for that single table. And then you roll out to the the overall tables that you have from the system, and the idea is to generating a sort of Jupyter notebook, incorporating with the report together with the source code for the graph. So the user is able to edit on top of that. And finally, we have dashboard templates, which is basically to creating the initial draft of the dashboard that the countries can adopt. So a little bit deeper on how we actually can achieve this. So for the single table analysis, after data retrieval, we start to reshape the data, pull all the constant attributes into a context for the model. And then we also slicing the data series and on the recent periods by random combinations of the breakdowns. And after that, we call the AI models to generating the reports, the codes for each slice. And then finally, we do the consolidation and to get the report as you see on the right-hand side, and also the graph codes and together with the charts. And the second phase and third phase is still ongoing. And this is basically, if we're able to do for the single table, we can rule out for all the tables. But here we also incorporating the knowledge by analyzing the historical labor market reports and also try to learn the tone and layout. And then we try to consolidate it as a single market report. And for the dashboard, and this is actually take advantage of what is already in the community, the dashboard generator, which is an open source tool that is using the SDMX data query in JSON. This is a hackathon winner from 2023. And then the idea is to learn from this existing dashboard JSONs and to generate a template in JSON. Here I want to highlight the key message that we're through this journey that we've really benefiting from SDMX, which is SDMX really empowering the AI implementations. So you see that we have data complexity. We try to integrate data come from different agencies in various formats. And then through SDMX, we're able to do it with a structured and harmonized information and through standardizations. And then we also have the API allow us to retrieve data up to date. And of course, for the data semantics, you not only have the data points, but it is required to have the context, the semantics for the model to understand. So this is where we can have the rich metadata thanks to SDMX. Of course, we have the global communities. The ecosystem help us to have tools like dashboard generator, the PY SDMX that we can use as an open source tool. And final points for you to reflect. We see that SDMX naturally facilitates such automations and AI integration. And also, just to highlight one benefit from this, simply offering a product in multiple language, it could be a very costly for an organization like us, and AI just make it so seamlessly. The zero consolidation it still remain question because we found that maybe it incorporates some knowledge by itself. For example, it interprets the graphs and the codes based on the his understanding on the COVID impact, etc. But yet to be final approved from the field testing. And there is a trade-off between AI and also predetermined programming. So we found that we want more insights by AI, then we were also increase the risk that generating by the codes, that fill the graph. And the final one is that can we really generalize our analytical core beyond the labor context and into a more general context? I think this is something also enlightened with the MCP. Maybe we have to think something more in general, maybe can fit for the financial sectors and others, right? That's all for me, and thank you.
Thanks, Yutung. It's really impressive what has been achieved the last couple of years. I remember that in Bahrain, in the previous global conference, we were talking, everyone had some ideas what we could do, and now 2 years later, so many very concrete applications out there providing context, like we just heard from UNICEF or now the ILO. And so I think I'm really looking forward to the next conference in 2 years' time. I think we'll be amazed. Developments are going so fast. Thank you. Last presentation of this session is by Simona Rosnovic and Davide Rosnovic, co-founders of Inlook.ai, an AI startup focused on transforming access to statistical data through intelligent search and visualizations. Expectations are high, and the floor is yours.
Hello, we are the founders of Inlook.ai. We started by building the AI search engine for statistical datasets, and then after working for a few big statistical organizations, we set our vision higher to build the AI infrastructure for SDMX.
So how did we start by building the AI search engine for statistical datasets? Well, first talking to the users. So basically after talking to more than 100 people, we discovered that some search very broadly, and some others instead know exactly the specific time series they are looking for. And what we are trying to do is basically to address both of these type of users. But we can't do this through a standard chatbot because they can't provide 100% trusted data. And if we have this standard textual chatbot, they often require several interactions before the user actually gets to the specific time series. And finally, they also lack of a proper visualization interface. So what we did at Inlook is basically build this system in which you can type a query in the search bar and get an interactive chart, a table, and the source for the exact trend in just a few seconds. We provide 100% trusted data, and we target both broad questions and very specific questions, and the platform is very easy to use and visual first.
As an example, we worked for OECD to address 3 main priorities. Building a system which is very cost effective because they have a large external user base, so public use. They didn't want any risk of spreading misinformation, and they were mainly interested in public use again, with an eye on internal use. So the system currently working for OECD is works on all the 1,500 data flows. And for example, here we type what's the tax pressure for companies in Switzerland versus Italy since COVID time. And the system is currently retrieving the top 10 datasets first, and then refining the search to rank the really top 3 in order. So the AI is also providing a justification to guide the user in understanding if the retrieved data flow is really effective for the outline the user query. So we see this yellow band here, which is the highlighted period, and it's the AI which automatically extracts the time range the user implied in the user query. But you can also, of course, drag manually this slider. And the source here redirects exactly to the specific data flow in the OECD Data Explorer with filters already applied. So the table here is showing the same data points that you see already displayed in the chart. So as we see also, the dimension values have already been applied by AI for each of the dimensions, but you can also quickly add them manually. You can change the chart to bar chart, for example. And you can see this AI-generated description, which is often very effective for end user to just get a quick glimpse of what the dataset is about. But there's the full description from OECD often is much longer and is also here in the notes. And this is the second and third data flows in order of priorities.
So we talked about public use, but what about internal use? So we thought that the best way was simply to use our Inlook search engine and couple it with the MCP protocol. So this is very simply how it works. So a user types a question on Claude, Gemini, or ChatGPT, which have access to our tool, and this question is redirected to the Inlook search engine, which performs exactly the search that we showed before. It retrieves the specific time series, and it gives this time series back to Claude, for example, and which re-elaborates all the final result. So then, while we were doing this, we thought, wait, maybe this is a broader problem than we think, and all the people, not only people in statistics, they search for statistics on Google or ChatGPT. But Google and ChatGPT, they don't have access to official statistical data sets. So they make up numbers, or they avoid answering, as we saw before, or they refer to articles. So you see, this is the iceberg of all the data that is contained in a statistical organization. And just the pinnacle of that is visible through ChatGPT. Most of the information is contained in statistical data sets that are hidden. So if I ask on Claude how many homicides are committed every year in the Swiss canton of Basel, this information is not publicly available in articles, so they try to make up a bit of numbers. So they don't reply exactly. Same on ChatGPT and same on DeepSeek. What we wanted to do is to really uncover all the iceberg. So this is very quickly how it works. The user types a question, how many homicides are committed every year in the Swiss canton of Basel? Claude says, oh, I have this tool, can I use it? I provide this access. After a few seconds, Inlook performs the search, gives back the reply to Claude, which re-elaborates the answer and gives back all the specific numbers. But not only the numbers, you see there are the specific notes that are only present in the datasets of the Swiss Federal Statistical Office, like the Swiss crime code notes, and so on. So, you know, while doing this, we already presented it in Geneva some months ago, and we thought we can probably make it available for everybody because everybody is using, is accessing ChatGPT or Google and so on. And we got a very strong interest from a couple of Nordic countries, but I turned in the question to you. If we find at least five statistical organizations, we can go and propose this solution to be integrated natively within ChatGPT, within Gemini, so that everybody can access official statistics easily and in a trustworthy way. But then, you know, we talked now about the MCP, we talked about the AI search engine, but we think that you can make one more step at this point, and the future is actually here. So this is the proposal that we made to the International Labour Organization, a request for proposal, literally a few weeks ago. And basically, they had more an internal use interest with an eye for the public use. And of course, talking to them, we discovered that they really cared about their metadata, about the metadata being very precise. And so we thought maybe we can do something on that using AI. So this is the full detailed architecture that we built and is available. We have 30 pages explaining all of that. But I leave it to you if you want to give it a look later. I want to very clearly show how it works, like the whole life cycle. So we have the AI search engine, the MCP. We talked about it before. But then, you know, out of all the queries that we can collect from the users in an aggregated way, we want to understand who is searching, what they are searching, how they are searching, and if they are finding or they are not finding what they are supposed to find. And then after this, which is basically UX research, which we are implicitly conducting for OECD, but then we think, wait, we have some cubes, SDMX cubes, and they have some problems like sparseness of data. They have problems like a little, like descriptions that are not really suitable for the users, that user maybe don't understand exactly. So we can use AI to facilitate metadata refinement. And after that, eventually, we can get to simply facilitate SDMX metadata modeling. So this means that we can help drafting the creation of the cubes exactly. And this means that we are literally improving AI readiness, and we are closing the feedback loop. The next search will be easier for the users. Users will understand better, and yes, this is simply what we mean by AI-first statistical organization. Thank you.
Thanks, Simone and Davide. I think this is Unicum, two brothers presenting at the conference like this. Compliments. It also shows how important startups are. I mean, all these smart, quick technological developments combined with our statistical knowledge can be very powerful. I like this AI look. I mean, just looking at what the MCP-enabled LLM gives for answer, and then how should we improve the metadata. Because this morning we said we need this good metadata and then have the access, but indeed there's a feedback loop, and thanks for pointing that out. So when I started chairing this session, I said to organizers, no way we will have time for questions and answers. I mean, 8 presentations and 1.5 hours, but we do actually. So it's not due to my chairing, but to the presenters who kept perfectly the time. So we want to make use of these 5-6 minutes we have left to ask something to one of the presenters. Yes, Eric? And then you. Yeah, Mr. First, Eric.
I would actually go to the point that Simone and Davide made on, in a way, knowing better the users. And I think this is something that previous presentations somehow hinted at. For example, Alberto, the starting point was the problem of lack of usage of data, actually. But I was just wondering, how do presenters see how knowing the users will transform the way we want to develop these applications? In many cases, the posture is also very much still supply side. I have AI, I need to make it AI ready so people can access it more easily. But then how can we perhaps switch the perspective so we really start from the user side and try to understand, how in a way users will be different, even will cognitively evolve, if you like, and how their needs, their way of using the data will evolve, and how we can be driven by that. And so here, is there a sort of switch of perspective that we should also be thinking more about? Thank you.
Yeah. Question here in the front. Here.
Thank you. This is Wei Chen from IO. Thank you for the presentations. It's really eye-openings and a lot of inspirations. But my question is about the metadata in the SDMX, especially for those people who has implemented certain solutions using LLMs targeting the SDMX APIs. Like, my understanding is that no matter how smart the LLM model is, eventually you are still tagging the metadata in the SDMX. So you depends how you organize your metadata in your SDMX API, depend how these informations, like is it complete and or there's a lot of redundant information that could happen in the SDMX API. So based on your experience, like how do you see the effort of creating the AI solution and the really managing and refining the SDMX structural metadata? Like what is the balance between these two efforts?
Any other questions? David and Simone, I think it's really on your area, right?
to write down something.
Yes. So regarding the metadata, yeah. In fact, so I like we personally think there are really 2 points. One is, of course, like AI cannot know everything about what the data flow is supposed to be if that information was never written before. So basically, there are some things that AI can directly put in front of the, let's say, an internal administrator, and the internal administrator should simply click, yeah, confirm, because sometimes the metadata is simply not there, but should be supposed to be there, and it is easy to just, it's simply like retrieving something. For example, I don't know, there's maybe a description for a specific dimension, value, name, or dimension name, and sometimes it's mentioned, sometimes it's not even mentioned. So in some data flows are complete, some are not complete, but nobody knows why it was never written. So that case for AI, like it's very easy. The information is there, you just have to basically clean the surface and such that each data flow has the same information and it's complete. So that is something that AI can fully do, and the administration will simply click, okay, okay, confirm. And then there's another part. Another part is, let's suppose that some data flows should have some information, but it was never written in the first place. So in this case, AI can guide the administrator in understanding first that, okay, something should be maybe improved, because sometimes something is present, but it's very concise and not enough. So help the administrator understand it should be improved, and with some very specific suggestions on what could be written there. And it should be responsibility of the administrator to say, okay, I'm the expert here, or I should take the expert in here, and according to AI suggestion, okay, AI is telling me, okay, maybe some specific more information about this labor system code should be required because I saw it in the other data flows, but I don't know as an AI what you should write here. Okay, but you should add something here. Okay, then I call an expert. Okay, the expert should say, okay, the code is this, maybe add this here. And so it's like, in this case, it's AI guiding with specific suggestions on how to improve, but the administrator is still responsible for this. So these are the 2 points.
Thank you. Julia, you want to come in?
Yeah, so as a general rule of thumb, but I think it is what they experience as well, the most critical metadata information is exactly the metadata that the AI cannot produce by itself. So if the metadata can already be automatically produced by the AI, that's not the most critical one. The critical one is the one that you have, but the AI cannot guess.
Yeah, maybe to address your point around users, I think in UNICEF, working as a global team, our, let's say, business users are the country offices. So at least in this exercise, these are the guys that are gonna sit to a ministry or to a government. So in our next step, or what we receive from them is that if we present to them a country brief, then they will actually think this is useful, but we cannot scale, right? So this is something that we trigger back, and sometimes we don't think. But yeah, essentially, it should be definitely part of the process, and maybe in the UN organizations we don't have that much incorporated that part as in the private sector, where you have let's say you have a lot of clicks from users where you can act upon. Yeah, definitely that's part of the loop that we need to close back, and this is something in our part. It's not only the collaboration across our teams, but also once we have this, have some input back from at least from us will be country offices, so country representatives, unit chiefs that are the ones that are this product will be valuable. So yeah, I think I take your point as something for us to commit in our everyday work, I would say. Thank you.
Thank you. Is Jens, Lisette, or Alex, Rafael, Bianca want to comment on the questions on users? And I just want to give the opportunity. Thank you so much. It's really energizing to see. You do. Okay.
I actually do have a question for all the speakers in the room, and myself included. So one of the things that I notice is that there is some level of redundancy in our effort. I think that I've seen at least 3, if I'm not mistaken, MSP being developed. I've seen various attempts overlapping, which is great. It means that there is a lot of different solutions already found, different problems already faced and solved. Should we try and converge? Should we try and make things together?
Yes. This evening we have a SDMX sponsor group steering committee, and this is exactly the topic. I mean, when things go so fast, like the MCPs, they were not delivered so long ago, and already today we see 3 applications. It's good that we exchange things like we do now, and now we have to see how we work together. And it's not bad that there are different applications that can exist next to each other, but the basic, how we make SDMX AI ready, what we mean by that, especially the semantic and the context part, is really great to work together. So I think the SDMX community is a great place to do that. So that's why, for example, the IMF wants to put ours, that GPT product, in there, like other product, like what the BES presented on their approach. And then we can really work together, share tools, etc. But in this stage, it's not bad if there are different experiments, people doing similar things, and conference like this, and the steering committee will bring those things together. But it's a great question. Now I'm going to conclude, because we need coffee. It's really energizing, so how much has happened. And it's also great, the development. I said it before, 2 years ago there were many ideas. Now there are many things realized. And I think in 2 years' time we'll be amazed what has happened. So we're statisticians. We're trying to make data that matters. And in order to do that, we have to provide context, like Shutang and Alberto described. We have to make data found where people look for it. So we have to ensure that where people look for data, search engines, chat box, our data is there on a good way. Don't give away our data, but make it accessible in a way that still is a large distribution and a good use. And I think we together can do it. The SDMX community has shown that, and I'm really optimistic and positive how we will take this forward. Thanks to the speakers again. Let's give them a round of applause. Thank you so much.
We should make that call that we have scheduled.
And see you back here at 4 o'clock.